Okay, let's try this question. Here they want us to determine which of the compounds shown has a higher vapor pressure, and they show us HCl and HF. The first step in these problems is to determine if you're looking for the compound that has the stronger intermolecular attractions or the weaker intermolecular attractions. We know that high vapor pressures are associated with weaker forces. I want to go ahead and write that down right now. We're looking for not the strongest force, but we're looking for the molecules that experience the weak intermolecular attractions. If the attractions are weak between the liquid molecules, more of those molecules are able to escape into the vapor phase, the gas phase, and therefore we're going to build up a bigger pressure of those gas molecules, a bigger vapor pressure. So let's go ahead and determine the intermolecular forces each of these compounds experience. Now, let's be systematic. Question 1, are either of these compounds a metal with a nonmetal? The answer is no. We don't have an ionic compound because there's no metal in our structures. Question 2, are either of these a network covalent material? No, they're not our fantastic 5. So we don't have a network covalent. And we also, question 3, do not have just a metal. We don't have a metallic structure. Now at this point, we know we have molecular compounds held together by weak intermolecular attractions. To determine what those interactions are, we should draw the Lewis structure. These Lewis structures are easy for our molecules. HCl is a single hydrogen bonded to a single chlorine, and then my chlorine has its full octet. The same thing is true for the HF molecule. We just have linear molecules right here. Now our next question is, do either of these molecules have a hydrogen bonded to a fluorine, oxygen, or nitrogen? And the answer is yes. HF is capable of hydrogen bonding. I'm going to write that as HB. But since it has hydrogen bonding interactions, it also has dipole-dipole interactions, and it has London dispersion interactions. And I just abbreviated those. Now, what about HCl? We don't have H-phone, but HCl is a polar molecule. Chlorine is more electronegative than hydrogen. It's going to pull electron density towards it. This is an asymmetric molecule. And because it's polar, hydrochloric acid, or HCl, experiences dipole-dipole interactions and London dispersion interactions. Now, if you compare those two interactions, hydrogen bonding, dipole-dipole, and London definitely trump dipole-dipole and just London. Now remember, this must be the stronger interaction, but we're looking for the weaker interactions. We're not going to pick the strong one. We're going to go ahead and pick the molecules that are held together more weakly, and therefore the higher vapor pressure is going to come from the HCl. I hope that helps. Take care.